Here's my color machine Simulink model. I have an IR sensor from the Simulink library positioned to the left. Based on our experiments earlier, we can start structuring a function around what distance an object is from the IR sensor. And that model was created just by having the proximity and display, not having this MATLAB function inserted yet, or the RGB LED. So let's click into the MATLAB function and explore how it's constructed. If the proximity reading is less than 5, and this is in line 2 right here, is less than 5, then the output green will be 255. And then we have an else if the proximity is greater than 5 and the proximity is less than 30, and this is in line 6. Notice how the AND symbol is a double and also notice how I've used an else if here. You can have unlimited amounts of else if to suit your logic within a function you're building or a script. And then what I have in this function though is an else. And in the else portion of my code, it's going to output a value for red at 255 if none of these conditions match what's going on with an object in front of the mini-Q. So I'm going to go back to my original model here, and I've set everything up for external mode with an infinite time frame for it to run. And I'm going to press the play button. So my simulation is up and running now. As I move my hand back and forth from the mini-Q, already the display values are changing. But if I actually look at the mini-Q and move my hand back and forth, the LED lights are also changing according to the function that we created earlier and what it outputs to the RGB LED. When I'm done looking at my Simulink model here, the color machine, I'm going to press stop. So here's a similar Simulink model to the one we just looked at with the addition of motors, motor block that the function feeds output to. So let's take a look at this function by double clicking into it. You'll see that there are two additional parameters that need to be used within the function, MR and ML, which stand for motor right and motor left. You can then see that equals color machine with motors. That's the name of my function, and it matches the name of my sketch. And then within it, proximity. Basically, that's going to take in the sensor readings. So input proximity, output colors and motor speeds. So if the proximity in line 2 is less than 10, then it'll be the color green, and both motors will be moving in the same direction. You can tell that by them both being 255 in the positive manner. So then it goes into an else if proximity is bigger than 10 and proximity is less than 20 within a range. The color is going to be red, and you can see this time the one 255 is positive while the other is negative. So what that's going to affect is the direction of the mini-Q. It's going to pivot in place. Otherwise, what's going to happen is the mini-Q robot will go the other way, because now we have motor right as minus 255 and motor left as positive 255. There will also be the color blue. So let's go ahead and let's try out this model now. So here's my model running in external mode. Simulation time is 6 seconds in. As I move my hand back and forth from the mini-Q robot, you'll see that the display values change, and the motors are running continually because those are the functions that we've given it within our code. So that time I just stopped the mini-Q manually by pressing the power button. But this is a color machine with motors function, and it's basically an obstacle avoiding robot too. So try out the code, put it on the ground, experiment with different motor speeds and perhaps different colors on the RGB LED, and you can do this all by double clicking into the function and changing the numbers right here.